In this video, we're going to focus on simplifying algebraic expressions. So far we've looked at evaluating algebraic expressions using substitution. We've looked at finding equivalent expressions using the distributive property. And now we're going to look at simplifying algebraic expressions by combining like terms. So you should have this paper or worksheet in front of you, and it should be titled Simplifying Expressions. You want to keep this with you throughout the lesson and make sure you're taking notes and completing these different parts as I go over them in the video. There are two parts that make up simplifying algebraic expressions, and the first part is using the distributive property. We've reviewed using the distributive property before in terms of algebraic expressions, but just to kind of rekindle our thoughts, remember that the distributive property looks something like this, where we have a number that is on the outside of the parentheses that is being multiplied by whatever is within the parentheses. So we remember that we want to share the number outside the parentheses with both pieces or terms that are inside the parentheses. So we want to share the 4 with the 2e by using multiplication, and then we want to share the 4 with the 3, again using multiplication. To combine those two things together, we would add them, and we now have two different pieces. We have 4 times 2e and 4 times 3. We can simplify or solve the 4 times 2e, but we cannot actually get it down to one final answer because we don't know what e is. But we can multiply 4 times 2 and get 8, and then bring the e along for the ride. We can, however, solve and get one final answer for 4 times 3 because they are both whole numbers, and we know 4 times 3 is 12. To finish this expression, we would put an addition sign in between, and our simplest form of our expression, 4 times 2e plus 3, in parentheses, would be 8e plus 12. Again, this expression, 8e plus 12, is equivalent to our original expression of 4 times 2e plus 3 with the 2e and 3 in parentheses. The second piece that falls under the idea of simplifying algebraic expressions is combining like terms. And the thought of combining like terms is kind of like when we are working with a regular numerical expression and we put together two whole numbers, we put together fractions, we put together decimals, because those things are alike. We can combine decimals and whole numbers because they don't have a variable attached to the end. So for example, if we're given the expression, let's just stick with the same one, 80 plus 12 minus 2e plus 4. We can see that we have an 80 and a 2e. Make that look a little bit more like an e. Because these both have the same variable attached to the end, I can combine them together. The most important thing to remember when you are combining the terms is that you should always go ahead and circle whatever symbol is in front of the letter. So in this case, if I look at the expressions, or the terms, the terms, 8e, that's the start of my expression. Then I'm going to see that I have minus 2e. So I'm going to go ahead and circle those two things because they both have an e attached to the end, and I'm going to rewrite them together. So I have 8e minus 2e, and that takes care of those two pieces of my expression. The next pieces are my plus 12 and my plus 4. Again, those are two whole numbers, so I'm going to go ahead and tack them onto the back or add them onto the back. So I'm bringing down my plus 12, and now I'm going to bring down my plus 4, because if I look now, I can see that anything that's in green, I can combine, and anything that's in yellow, I can combine. This is the idea of combining like terms, because if I have 8 e's and I take 2 e's away, I would now have 6 e's, and if I have 12 plus 4, I would now have 16. So my final simplified answer, or simplified algebraic expression, would be 6e plus 16. And again, I can't solve until I know what e is equal to. So again, one more example with the idea of combining like terms. Again, you want to have some colors in front of you so that you can make sure that you can circle or box the different terms. So if I look, I'm going to see that I have 9x, and I'm going to circle that, and I'm going to see that I have 4x, but I want to make sure I circle the minus sign in front of the 4x because that symbol goes along with the term 4x. I'm now going to rewrite 9x minus 4x. And I've already used those because they're circled, so I don't need to worry about them again. Now I'm going to look and focus on my plus 5 and my plus 2 because those are both whole numbers. And I'm going to go ahead and add them onto the end of my expression that I have set up so far. And now I can combine whatever's in green. 9x's minus 4x's would get us to 5x's. Again, I'm just subtracting the whole numbers and then bringing the x along for the ride. Same thing with your whole numbers. This is what we're used to doing. 5 plus 2 is 7. So my simplified expression for 9x plus 5 minus 4x plus 2 would be 5x plus 7. So let's go ahead and jump to your worksheet and looking at the examples that are on your worksheet. If we take a look at example number 1, you're going to notice that we have the expression x plus 9 minus 9. So these are already grouped for us. We see that we have x by itself, and then we have a positive 9 and a negative 9, or really truly 9 minus 9. Well, if I have 9 minus 9, that's going to get me down to 0, and then I'm left with an x. X plus 0, like we know with anything, 2 plus 0, 1 plus 0, always equals the number itself. So we're going to go ahead and add x to 0, and once we add x to 0, we're going to get an answer of just x. So our answer, or our simplified expression for x plus 9 minus 9 would just be x. Taking a look at example 2, I'm going to go ahead and rewrite this. Remember that when we have a number next to parentheses, that means multiplication. So I'm going to write that as 2/3 times 3/2. And whenever we have a number or a fraction next to a letter, that also means multiplication. So I'm going to go ahead and multiply that as well. Notice that I'm writing out my dots in between each part of my expression. I'm going to go ahead and work with the fractions first, and I'm going to type that in on my calculator as 2/3 times 3/2. And you should be doing the same thing. And what I find is that this results in a 1. So I really have 1 times x left in my expression. Well, as we talked about before, if we have 1 times 2 or 1 times 3, it's always going to be the number itself, 2 and 3. So, proving the same thing, when we multiply 1 times x, we are also going to simply get the letter x. So when we simplify this expression, 2/3 times 3/2x, we would get a final answer of x. Next piece is looking at part 2, and this is kind of looking at the idea of combining like terms. So again, I would go through and I'm going to underline or circle anything that matches or looks similar. I notice I have a 7x and I have a 5x. My 5x is positive, so I'm going to go ahead and I'm going to box the plus 5x, and I'm going to rewrite that as 7x plus 5x. Now I'm going to see if I have any other variables attached to a number. I don't, so I'm going to jump to my whole numbers. So I have a plus 4 and a plus 8. So I'm going to go ahead and bring those down and add them to the end. And now I have my rewritten expression where my like terms are grouped together. So I have 7x plus 5x plus 4 plus 8. So if I have 7x's and 5x's, I'm going to go ahead and add the 7 and the 5. When I add the 7 and the 5, I'm going to get 12x. And when I add the 4 and the 8, I'm going to get 12. Again, I'm going to bring my symbol of an addition sign down because that's what's connecting the two different parts, the yellow and blue parts of my terms. So my final simplified answer would be 12x plus 12. Looking at example 2, again, I'm looking for my common terms. So I see I have 2x plus 6x. So these are already kind of together for me, but I'm going to go ahead and rewrite this in green. And then I'm going to look and see that I have a plus 10 and a minus 3. So I'm going to add that onto the end. And I'm going to go ahead and combine my like terms. I'm going to add the 2 and the 6 and get 8. Bring my x along for the ride. Plus 10 minus 3 is 7. So my final simplified expression would be 8x plus 7. Let's go ahead and look at one more example with this. And I want to look at the example of 7x plus 2 minus 3x squared plus 2x. So if we take a look at this example, I want to go ahead and look for the things that are the same. So if I see I actually have two variables, I have an x and I have an x squared. These are not the same variables because this x right here is only x to the first power, where this x over here is x to the second power. So they do differ. So they're going to represent two different variables. So right now, what I'm going to do is I'm going to go through and look specifically for my single x's. So 7x, and then I see this plus 2x. So I'm going to go ahead and rewrite that as 7x plus 2x. Then I'm going to look for anything that's different. I see I have a plus 2, and that's the only constant or whole number that I'm working with. And then I see I have a minus 3x squared. So I'm going to go ahead and add my 2, and then I'm going to subtract my 3x squared. And I'm going to look and see if I can combine anything that is similar or alike. I see that I do have two terms that have your matching x's. So I'm going to add the 7 and the 2 and get 9x. Then I'm going to add 2 to that and subtract the 3x squared. I cannot combine anything else because none of this looks the same. So my final answer for this specific example would be 9x plus 2 minus 3x squared. To review very quickly, I want to look at the distributive property, and when we're working with the distributive property, we did discuss this a little bit at the beginning of the video. It's important to remember that we are starting with our number on the outside, and we are sharing it with whatever is inside. So in our first example, I'm going to share the 2, and I'm going to multiply 2 times x plus 2 times 4. I can combine the 2 and the x and do 2 times x and simplify that down to 2x. And I can combine the 2 times 4 to get to 8. So my simplified answer for this original expression would be 2x plus 8. Again, similar function, similar strategy to the first example. I know that I'm multiplying 4 times whatever's inside my parentheses, so I'm going to do 4 times 3x. And 4 times 1, and I'm going to subtract this time because that's what's in between the 3x and the minus 1. I'm going to go ahead and combine 4 times 3x and get 12x, and then I'm going to do 4 times 1 and get 4, and have my simplified final answer of 12x minus 4. The reason why we looked at the distributive property is because in these examples, we actually need to do the distributive property first and then combine any like terms together. So if we take a look at example 1, we're going to share and focus specifically on this first piece of our expression. So we're going to work on sharing the 6 with the 3x, and we're going to have 6 times 3x plus, share the 6 with the 5, 6 times 5, plus 2x, and that plus 2x is just what's left on the end. I'm going to go ahead and combine the 6 times 3x and get 18x. I'm going to combine the 6 times 5 and get 30. and I'm going to bring along the 2x again because there's nothing I can really do with that. Now I can go ahead and start to simplify this expression because I have no more parentheses and no more multiplication pieces. So now I can combine things if possible. So I'm going to go ahead and look for any terms that look alike or look similar, and I see I have an x here and an x here. So that tells me that I can combine the 18x and the 2x. So I'm going to go ahead and rewrite that as 18x plus 2x, and then I see I have a plus 30, and I'm going to bring that on and put it on the end with a plus 30. Now I can see that I can combine the 18x and the 2x and get 20x, and then bring down the 30. I cannot combine these two items, again, because this has an x on the end, 20x, and this 30 does not. So therefore, my final expression, simplified expression for number 1 would be 20x plus 30. Looking at our second example, we can see that we have 9x plus 5 plus 8 times, in parentheses, x plus 3 minus 7. Again, this looks like a lot, but just take your time with it. We're going to focus specifically on the 8 times x plus 3 because this is where we're going to use the idea of the distributive property. So now that we know we need to use the distributive property, we're going to go ahead and share. So we're going to rewrite the first part, and we're going to have 9x plus 5 plus, and now do 8 times x, because that's sharing the 8 into the parentheses, plus, share the 8 with the 3, 8 times 3, and then bring along the last little bit of the minus 7. So now I'm going to go ahead. I can't do anything with the 9x yet. I can't do anything with the plus 5, but I can combine the 8x. So I'm going to go ahead and rewrite this as 9x plus 5 plus 8x. I can also combine the 8 times 3. So I'm going to put another 8x plus 8 times 3 is 24. Can't do anything with the minus 7 yet, so I'm just going to bring that down as well. Now, looking at this expression that I'm boxing in green, I can start to combine my like terms. So I'm going to go ahead and look for things that are alike or that look alike. So I see I have a 9x and I have a plus 8x. So I'm going to go ahead and combine those two pieces together and rewrite them side by side. Then I see that I have a plus 5, a plus 24, and a minus 7. I'm going to add that onto the end, plus 5, plus 24, and minus 7. Now I can go ahead and combine my like terms. 9 plus 8 is 17. Bring the x along. Then I'm going to add, and I'm going to add my 5 plus 24 first, kind of like with order of operations. I get 29, and then I subtract 7. 29 minus 7 would get me to 22. So my simplified final answer for example 2 is 17x plus 22. Right now it's your turn, so you're going to go ahead and solve numbers 1 through 5 on your paper, as well as number 7. So you can cross off 6 and you can cross off 8. You're going to do 1 through 5, 1, 2, 3, 4, 5, as well as number 7. And your goal is to simplify each expression to get it into its simplest form to simplify the expression. When you're finished, go ahead and hit play, and then you can check your answers with mine. So by now you've probably finished your numbers 1 through 5 and number 7. Go ahead and check your answers with my answers. Look at the steps that I went through, check any mistakes that you may have made, and then go ahead and put this paper away in a safe place.